Sure. Hi. So I'm just going to take a few minutes to introduce you to the new journal by Cambridge University Press. It's called Flow. It's, as Kathleen just mentioned, it's a sister journal to the Journal of Fluid Mechanics. And we're very happy about this and very lucky to benefit from the experience and the great reputation of the Journal of Fluid Mechanics. This journal, compared to JFM, is an open access journal. It's going to have shorter format papers. And the key of the journal is that it's focused entirely on applications of fluid mechanics. That is where fluid mechanics is leveraged to achieve either a concrete technology or some very practical insight into nature. So also natural phenomenon. So again, we want to leverage fluid mechanics for the benefit of society or natural phenomenon. We won't have issues. As soon as we have good papers, we're going to publish them online. We've assembled a very strong set of editors who have very widely different, yet in some cases overlapping expertise. And I'll list them here. I won't read through them. We have a few different article types. A standard research article is going to be relatively slow, 15 pages. Like JFM, we're going to have a rapid section. So we call ours Flow Rapids. And that will offer shorter turnaround time. We're going to have something a little unique for journals in fluids, especially called case studies. So these are very ad hoc of one device or one phenomenon. Studies, and it could be from the point of view of industry, it could be a failure of a design, so very practical things. And then we have a couple types of reviews. I'm just going to share one more slide with you, but basically we're working under this hypothesis that the fundamentals of fluid mechanics are very well covered by several journals, including journals like the Journal of Fluid Mechanics. But we have a hypothesis that there's still a niche for a journal that's focused on the applications. And with this slide, I'd just like to summarize basically our proposal to you as potential authors and to readers. The first is a shorter format, open access. So we think we can have target a very wide scientific audience, not just fluid mechanicians. Second, for authors who are themselves fluid mechanicians or collaborate closely with them. Again, we hope to provide a much wider audience than traditional fluids journals while still benefiting from rigorous reviews from experts in fluids. So to readers of our articles, of our papers that are fluid mechanicians, we hope to offer you accessible introductions to other applications. So you might want to read this journal to see what other applications you might apply your fluids mechanics knowledge to have impact, so that your research can have impact. And then to readers outside of fluid mechanics, we hope to offer them an introduction to powerful tools of fluid mechanics. And to everyone, of course, we aspire to have very high quality, succinct papers that leverage fluid mechanics, which is so prevalent and ubiquitous. Thank you.
Thank you, Juan. Let me share my slide back again. So Juan will stay with us and hopefully we can take questions at the end. But just to let you know more about Journal of Fluid Mechanics and its start. So as I mentioned, JFM was founded by Professor George Keith Batchelor in 1956. And this is an excerpt from what Professor Keith Moffat wrote in the memoirs for George Batchelor. Until 1956, there was no journal that was devoted to fluid dynamics in all of its experimental and theoretical aspects. He then goes on to say that Batchelor perceived that a need for a journal of a new kind, one that would include papers covering a full range for those dealing with the most fundamental aspects of the subject in fluid mechanics, right through dealing with the applications in all of the sciences. So JFM does have that fundamental aspect, the advance of new fluid mechanics, and will also accept papers covering the applications of the sciences. And I suppose what Flow does, Flow covers new understanding in the new application and the impact, whereas JFM is looking on new advances in fluid mechanics. And that's the main difference between the two. But going back to JFM, on the left here are all of the editors-in-chiefs that we've had since the launch of the journal in 1956. And we're very, very pleased today that Professor Gray Worcester, who is the current JFM editor-in-chief, has been able to join us and will give us some of his insights of what he looks for in a paper. But JFM started at the University of Cambridge, and Gray will tell us about that as well, about the connection between JFM and DAMT, the Department of Applied Maths and Theoretical Physics, and also Bachelor was also heavily involved with the European Mechanics Society when the journal was launched. Just a few statistics and submission trends with JFM. So you can see that the submission goes from strength to strength every year. And there's a strong growth, about 10 to 15% year on year. And this year in 2020, we've just hit over 2,000 submissions already. And we've just closed our 2020 volumes with 975 articles and over 28,000 pages. So thank you very much to all of our authors, our referees, our readers that contribute to JFM. The pie chart on the right here shows our geographic distribution of our authors. So primarily our authors come from the US, the UK, France, China, Australia, Germany, India, Japan, Canada. So we want to increase more diversity around this ring and encourage you all to submit your papers to JFM and to Flow. Here, just to show you that JFM still remains one of the leading journals in the fluid mechanics field. JFM is in orange here, and you'll recognize some of these other leading journals as well. But we are and maintain our very good reputation, and we want to grow further and further increase the impact factor. That has been growing every year anyway, but to really maintain our lead here as the top premier journal in fluid mechanics. Here on this slide, I wanted to address some of the misconception. So it's often what I hear when I go to conferences, people tell me, oh, JFM is very slow. So I just wanted to say that JFM is not that slow. This is a graph for JFM Rapids. We aim to give you a decision within 30 days, within about a month. And we aim to publish, certainly on the Rapids side, we aim to publish a manuscript within 3 months. Okay, with COVID and pandemics, sometimes we've been a bit slower, but you should get your paper from submission to online in the region of 3 months. And for a standard, our times to publication is around 9 months. And sometimes people say, oh, you take over a year to publish in JFM, which is not true. So on average, our times to publication is around, from submission to getting online, about 9 months. And these are the different article types in JFM. We have standard articles, we have rapids, JFM perspectives are more like big reviews, similar to the annual reviews of fluid mechanics. And then we also have a focus on fluids. Now I'd like to point out to Professor Gray Worcester. But before I do that, let me introduce the panelists. So we're really pleased to join by the excellent panels of JFM editors. So we have Professor Gray Worcester, who's our editor-in-chief. He's based at the University of Cambridge, and his specialist area is in geophysical flow, flow related to ice sheets, sea ice, climate change, and fundamentals of frost heave. We're also joined by Professor Hae-Jun Choi. He's based in South Korea at the Seoul National University, and his expertise is on turbulence flow control, CFD, biomimetic engineering. We also have online on the panel today, Kenta Kawahara, who is based in Osaka University, and his expertise is on turbulent heat transfer. And also we're joined by Professor Xia, Ke-Ching Xia. He's based in SUSTEC in Shenzhen, and his expertise on the enhancement of scalar transport in turbulent flows, oceanic mixing, and internal waves. Without further ado, let me hand back to Gray Worcester, who's going to tell us a bit about what he looks for as an editor-in-chief in JFM when he assesses a paper. So Craig, over to you.
Thank you, Kathleen. And hello to everybody. Thank you all for coming. It's wonderful to see so many people online. And I'm just going to spend a few minutes sort of musing on what it is that JFM editors look for when assessing a paper. And I think in order to understand that, it's good to understand the history of the journal a little bit. And as Kathleen's already alluded to, before JFM came along, there were various journals in which you could find fluid mechanical research, going through engineering journals, physics journals, and mathematics journals, so specialized journals in their own right, and then society journals like the Philosophical Transactions of the Royal Society, for example. You find a lot of the sort of late 19th century, early 20th century fluid mechanics. And George Batchelor, as Kathleen said, recognized that there was a space here really for a journal that brought together all these different approaches to the study of fluid flow, which is a very rich and diverse subject. And so the idea of the Journal of Fluid Mechanics was born. And I think to understand the nature of JFM and what it is that editors look for, it's worth reflecting on the nature of George Batchelor and where he was as a scientist. And it's worth pointing out that he founded the Journal of Fluid Mechanics at a very similar time, just 3 years before he also founded the Department of Applied Mathematics and Theoretical Physics in Cambridge. And so I'm going to talk a little bit about that department because I think it gives us some insight into what George felt was important and what he wanted to reflect in JFM. So DAMT is a department of mathematics, applied mathematics, but it was actually a splinter group, and it split away not from the mathematics department, which existed before DAMT came along, but it split away from the Cavendish Physics Laboratory. George Batchelor and G.I. Taylor and all these early workers were there in the Cavendish, and I'm going to mention G.I. Taylor in particular in just a moment. And throughout its history, the department has also had very close ties with the Department of Engineering in Cambridge. And so you can see this sort of multidisciplinarity coming through with an emphasis on this interplay between physical understanding, mathematical interpretation, and engineering applications. And the other thing that's almost unique, but very special, certainly very special about DAMT, is that although it's a mathematics department, it includes a very significant, very large and significant fluid mechanics laboratory in its basement. I'll say a little bit about G.I. Taylor because, in fact, a lot of what George Batchelor felt was important was guided by his very deep respect and admiration for G.I. Taylor. And I don't know how many people know the history of G.I., but he started out really as a theoretical physicist. There's a lovely story where he ran an experiment to see whether the young slit experiment, the sort of fringes that you get in a diffraction grating, would still work at very low light intensities, where really just one photon at a time would be traveling through the slits and forming the pattern on the other side. And this experiment was going to take at least a month, maybe a few months. And so he set it all up in the laboratory and went sailing, which was a very popular pastime of his. And while he was out sailing, he flew a kite off the back of his yacht and made some measurements of atmospheric motions, the winds and the sort of turbulence in the air. And he came back, and that was sort of the start of his fluid mechanical investigations. So he was a physicist by background and an experimental physicist in that regard. If you look at his early papers, he was a very adept mathematician. And you have to look at the paper on Taylor-Couette flow, for example, to see that. And he was an engineer. One of the inventions, actually, of GI was the small anchor that yachtsmen use, and you may be familiar with, that rights itself and digs itself into the seabed in the manner of a plow, and that was GI's invention. So let me get to the main topic of this talk. What is it that JFM looks for? And often people come to this and say, well, JFM is an applied maths journal. It's looking for mathematics. But others involved in fluid mechanics are more keenly involved with observations or measurements, or these days, increasingly, with computation. But JFM is looking for not specifically any of these, but rather treats all of these aspects as tools to lead us to an advance in fluid mechanical understanding. And that really is what JFM is looking for, an advance in fluid mechanical understanding. That is also motivated by something other than the ability to solve an equation, for example. And this structure really gives us, I think, the structure of a paper. And JFM has always looked for a very clear introduction, narrative introduction that motivates the problem to be looked at. The bulk of the paper is in this middle section. That's where you present the calculations that you did, either numerically or analytically, the experiments that you did and what measurements were taken. And then most importantly, a conclusion. So when one's doing research, and I know this is particularly true perhaps of younger researchers, PhD students, when they first come in, they're very, very focused on this middle section. That's the hard work, if you like. But it's good even if that hard work starts with a motivation and an idea of where one's going. But certainly at the stage when one comes to write a paper, I would say that one needs to start thinking about the conclusion. What is it that you would like the reader to understand once they've read your paper? And with that in mind, I think that guides the whole structure of the paper from beginning to end, because you're trying to lead the reader from the motivation towards an advance in fluid mechanical understanding. So let's pick these two key ingredients apart a little bit, the introduction, the conclusion, the motivation, and the advance. So let's think about the motivation, and I've put here a couple of examples. This is a often quoted statement. I don't know if it's was actually made by anyone or if it's just a bit of a joke, supposedly from a referee's report, writing, "This paper fills an important gap in the literature." But you do read statements like that at the beginning of a number of papers. This seems to be a problem that no one's looked at before. Well, actually, that's not sufficient. Just because it hasn't been done doesn't mean that it needs to be done. It's not a sufficient motivation. Another sort of structure that one sees is represented by the following, and I made this statement up, but it sort of typifies some submissions that I receive. We present measurements on something very specific, you know, the CX-25B delta wing. I don't think that's a real thing, but I just put it there. And that's really a case study, a single case study from which there may be very important measurements made that are important for the designer and for the user of the product, but it doesn't lead to something necessarily that is generalizable to other shapes of wing or other areas of fluid mechanics. So I put these up as examples of inadequate motivation for a JFM paper. On the other hand, I mentioned this paper. Notice this was a paper that was recommended to me when I was a PhD student many, many years ago now, to read as an example of a well-written paper. And that's something you might think of in advising your students. Pick out a paper that you've really enjoyed in the past that you think is really exemplary in the way that it describes its science. But here in terms of motivation, we see that there is a motivation motivated by a variety of environmental phenomena. And then it goes on, we'll discuss a simple model of convection from sources placed in a finite closed region. So there's a level of abstraction there, out of which one can develop an understanding that goes beyond the immediate application that had motivated the problem. It was motivated by one thing, but the generality of what was determined within the paper can be applied to many other things. And I picked out a more recent example, but the same principle is involved, that the authors have started out by wanting to understand aspects of a range of applications, but in the paper itself, that's abstracted slightly into a study around something that is well characterized in the laboratory and from which one could determine widely applicable fundamental understanding. And so I put these forward as examples of worthwhile motivation. So what about the end of the paper, the conclusions? So it's a very, very important, perhaps the most important part of the paper, and the thing that I look for when I first receive a paper. I read the abstract in order to see what the paper might be about, and then I read the conclusions. You know, have the authors finished this paper by understanding something new that they want to convey to the wider community. And there are many, many submissions that simply present results. We carried out this study, and here are the results of the study. But they don't consolidate that into a set of conclusions that advance understanding. So it's important to identify what has been learned beyond the raw numbers of the results of the experiment, the results of the numerical computation, or the results of the analysis. And how can it be generalized? You know, that a broad understanding can be applied to other things. So I think that's important to bring out. And any of these methods of attacking fluid mechanical problems, analysis, experimentation, numerical computation, can be generalized by identifying what fundamental principles are involved. It may be that several case studies can be consolidated through the use of scaling that not only allows you to understand something general between those case studies, but allows the results to be extrapolated to other situations. Particularly important in geophysics, of course, where the motivation, the application is on the large scale, but often the understanding comes from an appropriately scaled laboratory experiment on the small scale. The other thing is, you know, is there a change of behavior in what's been observed? And if there is a change of behavior, have the critical conditions been determined? Ideally in terms of dimensionless parameters, so that this extrapolation can go on. Similarly, can you use your results to optimize a process? So not just, this is how this process works, but if I wanted to make it better, how would I go about doing that? And then very importantly, don't be afraid of saying what your paper can't do. What are the limitations of your study? We all make approximations in fluid mechanics, or, you know, we're limited by the range of parameters that we can explore in a laboratory setting, for example. So what are the limitations? How far can the results be taken? And that's a very important contribution of what you're doing. So in closing, let me try and answer the question a little more directly. What does the JFM editor look for when assessing a paper? Well, he's looking for positive endorsement from referees. And that's an important statement. It's not sufficient that the editor doesn't receive negative reports. There actually have to be positive reports. So reports that are simply acquiescent, well, sort of shrug of the shoulders, this is okay, I can't see anything wrong with this, somehow isn't enough. The referee has to recognize within the paper some significant advance and say, this is a worthwhile paper because. And then something about the process. JFM is a peer-reviewed journal, and here I've emphasized the word reviewed. Papers are sent out to referees who act as expert witnesses reporting to the editor. And it is the editor who makes the decision on the paper, guided by those expert referees. So that, I think, does need to be understood by authors, that the reviewers are not a jury or a panel who are casting votes. You've got 2 referees in favor and 1 referee who's negative. Therefore, your paper should be accepted because you've got 2 versus 1. Those referees' reports are advisory and will, in a good referee's report, will give reasons for the decisions, for the recommendations that are made to the editor. I think this paper is not sufficient because it doesn't do this, that, or the other. And it's for the editor to assess those reports from the expert witnesses who have given their opinions and to come to a conclusion about whether the paper should be accepted or not. But then if I change the emphasis slightly, JFM is a peer-reviewed journal. And at the end of the day, the editor is indeed guided by those expert witnesses. It is the whole community that contributes to what seems to be helpful and really advances the understanding of the community in fluid mechanics. And so with that, I'd like to thank you for listening, but also thank you to the many of you that I know exist who are listening today who have refereed for the journal. Your work is invaluable, and it really is a great benefit to the whole worldwide community, as well, of course, as to the journal itself in maintaining its high standards. So thank you very much, and I'll conclude there.